Dr. Anupam Kher, you are live.
It's not showing live.
Sir, you are live. Uh,
Okay. Greetings to all of you. Uh, Again, as a part of the AICT Prerna scheme, this is the that series of lecture, the part two of underground metal mining. So, in the previous lecture, we have seen the basics, the development of metal mining, how to develop the metal mining. Today, we'll be covering various underground mining methods. It's very difficult to pack up everything. In fact, every method may take more than our time one time, but I've tried to include all the methods here so that you can have a very fairly good look of all mining methods. Okay. Yeah. So this is about me. I'm Dr. Anupam Kher, presently working as assistant professor of mining engineering in Vishweshwarya National Institute of Technology, Nagpur. Okay. Yeah. So today, what we are going to do is to learn about the stoping or the underground metalliferous mining extraction methods. They are called as stoping. A stope is a place from where the in situ mineral is extracted. The stope is an excavation from where we get the ore. The stope, while being in excavation process, it is also stope, and the place which then becomes vacant after the extraction of the ore is also called stope. So stoping naturally is the process of carrying out the removal of ore from the ore body, that is stoping. So we'll try to understand. So there are various types of classifications. I am not entering into the classification system here, but understanding the classification of, there are many people who have worked on what classifications should be there for the stoping system. But most of the authors, most of the scientists, they have worked upon and they came to the conclusion that the type of stoping system, the classification of stoping system, can be taken up on one of the very important aspect, that whether the stopes are supported, unsupported, does it require some artificial support, or it can be worked upon without any artificial support. So based on that, the classification system was done, and the open stope system is considered here. In open stope system, in the 1.1, 1.2, 1.3, 1.4, you can see the further subclassified as underhand, overhand, brace stoping. So basically, then we also have a sub classification in terms of direction. In terms of direction, so classification basically based on the the support system which is being used, and the classification system, another classification system which is based on the direction of advancement in underground mining. So as you can see in point 1.1, it is underhand stoping. Okay, so underhand stoping, like when you divide the ore body from top to bottom in number of layers or slices, they are called as levels. So if we are, and normally the working is carried out from one level to another level. So either we are working from top level to bottom level, that means our advancement is towards the bottom level or the towards the lower level. We are always going down from top to bottom, the working direction is downwards. Then the stooping is called as underhand stooping. This is a purely directional term. Okay, so all the methods where we are going to study, they can be either underhand, they can be overhand, or they can be of a breast stooping, or they can be a combinational also, as you can see in 1.3. The overhand is exactly opposite, that from a lower level we progress upward direction. It can be vertically upward, it can be inclined upward, but the advancement within the ore body is always like we are moving towards the roof. The roof is in fact in the vertical or nearly vertical over bodies, it is called as back. And in case of the horizontal stratified deposits or like coal seams, we are always moving in the direction of the chest or in the frontal direction. The direction is like we are moving horizontally or slightly inclined, but we are always moving in the frontal direction. And then this is basically called as the brace stopping. So if you are moving, sorry, if you are moving downwards, then this is underhand stopping. If you are moving upward, then it is an overhand stopping. And if you are moving in the frontal direction, it is called as in the direction of the chest, it is called as brace stopping. Okay, so these are, just remember, these are the directional term. So whenever we consider any stopping method, for example, a stopping method can be room pillar, cut and fill. So it can be either underhand, it can be overhand, or it can be breast in terms of the directional stopping. Okay, so you have to consider this classification very well. So as you can see here in the open stopping, there are hardly any supports are given. Okay, so overhand, as you can see in all the cases, that this is the reference level here, this is the reference level here, that overbody, if you can see the thickness of this overbody, entire overbody is from here to here. Okay, and this is the lateral extent of the overbody. Okay, this is the lateral extent. And then you can see here that in all the cases here also, you can see when we are moving in this direction, that we are driving this drivage horizontal roadway, our direction is frontal. That means it is, we are moving in the direction of the chest, we can say it as a, when we are moving in this direction. But eventually the entire stope is being worked over the roof here, and that's why the term it comes at the overhand. Here also, that we are moving from this reference level to this level, we are always moving upward, then this is also the overhand hood. And then it can be a flat back, that flat backs means flat roof, or it can be as a reeled stope, it is called as reeled inverted benching system, like we do in open cast mining, but they are inverted benches. And then always moving from the lower level, and we are moving to this upper level. So probably next stage will look like this, something like this. Okay. So these are all open stopes with little support or no support. This the strata is so strong. The strata is so strong that it hardly requires any support, and that's why these are open stope, overhand stopping type of dimension. So overhand, you can see this is the upper drivage, this is the lower drivage, and the face advance is moving in the upward direction. Okay, suppose if I'm considering this overbody in the cross section like this, and this is our lower drivage, and this is our upper drivage, and our extraction starts from this level. We stop, like start cutting and move in this direction. Naturally we are always in overhand. Okay, if we are working from this upper level to the lower level, our work will become underhand. But if the same overbody is more or less becomes flat or very mild, okay, so what will happen, we are always moving either from this point or this point, almost always moving in horizontal, or we will say correctly as frontal direction, then it becomes breast stopping. Okay, yeah. So this is underhand. Now you can see that we are at this level and trying to reach from this level to this level. Naturally the inverted reel stops, it is going downwards. That's why it is called as underhand stopping. Same direction, the this is the upper one, this is called as the upper level, and this is called as the lower level. And you can see the direction of advancement of the face is downward. That's why it is the underhand stopping. And the small required supports are there, but this is not completely structural support that we are supposed to give. Okay, so now here you can see the advancing phase, which is a completely flat room and pillar type of system where hardly any support. So the phase advance is in this direction, the phase advance is in this direction, or even if I do the phase advance in this direction, the ore body being horizontal, the the method would be called as breast stopping, that we are always moving in frontal direction. Okay, this is again a wonderful picture of room and pillar. As you can see, these are the open spaces, these are the rooms, and these are the pillars, the square pillars are left. Okay, and the first the rooms are created and then the pillars are extracted, okay, in the later stage. That is, this is called as room pillar. Again, the advancement is in the frontal direction. This also comes under the category of brace stopping. Okay, yeah. So the conditions for room and pillar are mostly like it is a flat tipping, and basically the very extensively used in the coal mining. Okay, this is another picture of the room and pillar wherein you can find a continuous miner here, a continuous miner extracting the coal face, and the continuous miner, the coal getting loaded on shuttle car, and the shuttle car travels up to the feeder conveyor, and then it transport the coal transport is transported outside the district, and then it is connected to belt conveyor. It moves forward up to the surface. So this is again the horizontal or near horizontal, up to maximum of 1 in 4. In some cases 1 in 3 has been tried out, but the gradients are very mild. Okay, so this is typical of the open stoping method. The first method, what is we call them in India, is a board and pillar. It is not BOAD, it is BORD. So board, basically the definition of the board is an drive in underground. It starts in underground and it ends in underground, but it has a dead end, and that is called as a board. So the boards are created here, one board, two board, three board there, and then the crisscross manner boards are driven. And when the crisscross manner boards are driven, you will find that in between these kind of pillars are created. Okay, these kind of pillars are created. So this is a board, this is also a board, but in between these crisscross the pillar is created. Okay, so this is board and pillar. Another directional term which is being used in the stoping is transverse or longitudinal. So if everyone is able to see, this is a typical of an ore body which is drawn here. Okay, so let us consider this as the strike direction of the ore body. If I am making drivages and access roadways perpendicular, these are all perpendicular to the strike of the ore body. So if I am extracting the body, the starting point is here and ending point is here. That means I am working in the wall to wall, I am working in the wall to wall region. Okay, so suppose this is footwall, this is hanging wall. So if I'm running wall to wall perpendicular to the strike of the body, the directional term it is called as transverse mining. And if the extraction sequence is along the strike length of the ore body, I make slices of the ore body along the strike length of the ore body, this is called as longitudinal mining. This is another classification of the open stoping or other types of methods. Okay, so this is the one of the typical ways that you can see here. The strike direction is shown here at the bottom. Okay, the strike direction is shown here, and this is the thickness is already shown here. So if I am working along the thickness, that I start mining from this point and progress towards this point, then my mining is transverse. But if I am doing mining along this direction of the strike direction, then my mining would be longitudinal. Okay, so this is longitudinal, this is transverse, and this is longitudinal mining. Okay, see that I'm mining actually in the direction of the strike of the ore body, in the direction of the strike. All my workings are moving in this direction. It can move in this direction also, there is no issue, but the direction of mining within the ore body is along the strike direction. So that's why it is called as longitudinal mining. Okay, this is very clear from the diagram. So this is a wonderful way of like this ore body. Okay, this complete ore body is being shown here. Complete ore body with one very good diagram. This is another ore body here. Okay, so how it is being developed. So this is one level, this is another level, this is third level, this is fourth level, as is it can be seen in the diagram very clearly that this is a kind of overhand, that we are moving from this level and probably we'll have some level which is made here. So this is an overhand method which is shown here. Okay, this is a classical diagram of how the underground mines are developed. Okay, so first, as I told you, the room and pillar method we have already seen. Then next one is an shrinkage stoping method. So there is lot of discussion on whether the shrinkage method should be an open stoping method or it is an supported method. Okay, so what is being done here, that we actually move from this lower level to what is called as the upper level. Okay, in terms of different slices, and what is being happened, that some portion of ore is being left, some portion of ore, as you can see, the broken ore is being left inside the ore, inside the soap itself. This broken ore basically allows the workers and all the mining staff to stand on it and move. So as you can see, a person who is drilling the holes here, horizontal holes in the chest direction, that's why called it is called as breast drilling. Okay, some holes can be drilled, up hole drills also. So this acts as a platform. So this is the purpose of broken ore, which swells a lot after being blasted from its place. So you can remove 40, 50% of the ore at the bottom from the draw points, but this remaining ore remains basically up to the point where we are able to reach up to the crown pillar. We are able to extract everything. So this is basically used as a platform, although it may support the walls, but as such the conditions here, the ore strength and rock strength, both of them are quite strong, competent enough that they do not require any support, any particular somewhere roof bolts, cable bolts may be required here and there in the basically in the ore body in weaker zones, but basically this is the broken ore is not used as a support to the walls. That's why this method is classified under open stoping method. This has to be kept in mind from the exam point of view, that shrinkage stoping is to be considered basically as an open stoping method, or we should say as an unsupported method. Don't classify it as a supported method, because this broken ore is kept inside the basic uh, purpose of this broken ore is not to support the walls, but is to just create an working platform for the next to reach to the crown pillar, from lower level to the crown pillar. Okay, so this is the way that you can see that the broken ore is removed. Okay, yeah. So the next method is called as sub level stoping. It is again an open stoping method where the strata is quite competent. The basic important aspects of shrinkage stoping, room and pillar, is basically for an mild inclination or slight inclination over body, but shrinkage and the sub-level stopping other methods are basically for inclined or steeply inclined ore bodies. So what is being done in why this is called as a sub level? So in stopes are divided by two levels on the upper side, and the vertical boundaries are basically and raise and winds. So here the stope is formed. Am I right? The stope is formed, which is the boundaries of the upper boundaries of the stope are the levels, upper level and lower level, and the vertical boundaries are the two raises or ranges which are there. So that's why this is an upper level, this is an lower level. So in between, if we are going to make some more levels in between, we are further going to divide this ore property into more number of blocks. Then this method, these in between the major upper level and lower level, if some levels are driven, as you can see that this one level, this one level is being drilled, so that these are called as the sub levels, and that's why this method is termed as sub level. So you can see that from the bottom there is a slusher or haulage drift which is made here. Okay, it should be made in the competence strata, or then if required, then it should be properly supported. And above that there is a finger raise which is being carried out, and then these sub levels are created one by one. So if we'll see now, the all the sub levels are created, and these finger raises or shoots, basically they are a sort of this kind of feature. The shoots are this kind of feature here. Okay, if you see in the top, they will look like this in 3D. Am I right? Yeah. So what is being done now, we are able to extract this block one by one, one by one. It's a very progressive advanced method, large output, but basically the strata is competent in terms of rock and ore, both is quite competent. So if we are going to drill and blast this, everything material is going to fall down, and then we have got these draw holes, we can collect it here. Okay, if there is some LHD and everything is there, it can further bring it down through chutes, and then it is transported in the lower level. From this lower level it goes to cross cut, and then it is transported outside. So this is the funda of the, and you can see the sub level are being broke, like progress like this. Yeah. So the major advantage in sub levels that you can go very highly mechanized mining, as you can see in this diagram here, that what is being used is a modern day technology called as the ring drilling. The ring drills are being used from one level to up another level. So these kind of the drilling equipments are nowadays common in the advanced mines. We have got some of the mines in of owned by Vedanta. They are using this. Okay, so the what can be done, that this much of entire amount of block can be blasted, or from underground you can see this much of amount of block is also blasted from one sub level. And if I'm not wrong, in the previous blast, this much of amount of ore has been blasted. So these kind of methods are highly productive because of this drilling and blasting technology. In one single blast we are able to produce a lot of output from this. So as I told you, there are one method I have shown you. Another way is that instead of ring drilling, we'll drill vertical holes. We'll drill vertical holes and blast them one by one. Okay, so these are the two options we will have. We can see on one side, these are from one sub level to another sub level, the vertical holes are drilled, and you can see here that the the ring drillings are being used. The left hand side method, in many cases it is also called as VCR method. We'll understand it, but basically VCR method is an variation of sub level stopping, At this moment, we are considering this as a long hole drilling, and on the right side, we are considering this as a ring drilling. These are the two ways from which we can use the. Yeah. So this is ring drilling. You can see the ring drillings can have different patterns, and this is a typical of the vertical longitudinal section on one side and the cross section on the one side. So these are, so the ring drillings, as you can see, how the how it is moving up, and all the ore falls down here, and it is then collected at the haulage level, and then from haulage level it is taken up to the lower level. Okay, so this is typical of the sub level stoping. Yeah. And in this diagram, it can be seen very clearly that we are using what is called as long hole drilling. Okay. So if I'm trying to show you here that from top to bottom, the vertical holes are drilled. And what is being done here in the VCR method, the not the entire length of the hole is blasted. If we consider this complete one block, suppose if I am considering this complete one block here, I hope everyone is able to see, and let me draw this one also. So what we are going to do here, that first we'll blast this much of portion. In second stage, we will blast this much of portion. In third stage, we'll blast this much of the pressure. So now the current diagram here, as you can see, it has blasted 3 sections, and now we can plan for the 4th section here. So this way, we are retreating, vertically. All the ore which is the lower portion which is blasted first, the ore will naturally fall down by gravity. Okay, it will fall down by gravity, and it is accumulated here, and then it is taken up from the grizzly and finger ridges to this what is called as draw points, and the use, this is a haulage level. The haulage level, from haulage level it is taken to the cross cuts, okay. So these are the two diagrams which are explaining another variation of open stoping, that is a VCR method, vertical crater retreat. Okay. Yeah. So ore body is more or less 45 degrees or more. It width should not be less than 10 to 15 meters. It should be very large vertically. The grade of ore should be high, but it can be low to medium also. Okay. The depth, you can go for quite a good depth with this, but you should see that the oxidizing mineral is not there. It is not very suitable. So as I told you that we will drill holes in case from one sub level to another sub level. Okay, here I will draw, I think, two zones have been taken up. Was first this zone was taken up, then the next stage was this zone was taken up. So these kind of, we are taking up one portion at the bottom. So suppose this much of one portion was taken, second, now this one portion, third one it will be this much of portion, fourth it will be this much of portion. In that way the ore body slices are deleted, and since the holes are made, they are through holes. That means they are open at this end and they are open at the lower end also. Though if you will put anything, it will pass through. That's why a plug is given here at the bottom, and this plug basically holds the explosives and the charges are, so there is complete science. We will have to understand that if the charge is 6 times the whole diameter and everything, we'll have to understand these in details. Regarding one, there could be one complete lecture on every method. So this is VCR method, and it is also an open stoping. For plugging of the hole at the bottom, various arrangements of plugs are available. In earlier days there were wooden plugs available. Now next category of method is called as an supported method, where we require substantial structural support inside the ore body to support our working. Otherwise, the either the roof or the back or the walls may collapse. And there are the first one method which is called as cut and fill, and there are so many combinations of cut and fill method which are shown here. Okay, so you can just look at. So as the name that it says that cut and fill. So it is an again, in earlier days what used to be the underhand stopping method, but now it is predominantly an overhand stopping method. You can see that this the stopping starts from the lower level here. There is an again the bottom level is here and upper level is here. Okay, now we'll create one raise and winch to create the boundary here. Okay, so let's see that both the raises and winches are made. And once we, from this haulage level above leaving some pillar, if we extract this much of material, as you can see in this width also, if you have extracted this much of material, then it is, it goes bottom and then it is transported. But this, now the space which is created by the extracted ore is now filled by what is called as an waste rock as an support. And as you have seen in the open stopping method or shrinkage stopping method, we were using the ore as a platform. Now the fill material becomes the platform. The fill material, now you can see that this is our ore body and this could be our filling material. This could be the filling material. So we are always moving in the vertical direction from lower level. That's why it is an overhand method. As you can see that this is the boundary of the ore. This is the boundary of the ore, and this is our, this is the fill material which is now put in place in front of, in place of the ore which is removed. And this fill material is basically for supporting the walls, as this method is suitable for weak strata. The important factor here in cut and fill, that the ore should be competent. The walls and the surrounding strata in footwall and hanging wall can be less competitive, but the ore should be competitive. That is one of the requirements for this cut and fill. As you can see, we are moving one by one stages up, and the, as soon as we reach to the upper level, we will have to leave some pillar that is called as crown pillar. So we'll reach to this stage, then we'll reach to this stage, and accordingly we'll have to use the filling material. Now very important from the earlier methods, that this fill material is to be first brought down from somewhere. That is a cost that we, if we are required to have indigenous available, fine. If we don't have available, we'll have to purchase it in the market, transport it, and make the arrangement that every stove is filled with waste material. That means there is an additional cost. And how this additional cost will be covered, that means your ore value, the ore grade should be quite higher in other methods what we have seen. If the ore grade is not high enough, then it will not cover up the cost of waste fill. This is an additional cost which is going to, increase your operating expenditure, and it has to be covered up by good price of the ore. So this is typical the one arrangement where we are always moving in an frontal direction. Again, this is, we are always moving in frontal direction. This is a variation where we call it as a flat back method. We call this cut and fill flat back method. Next, where anything like nothing works, where nothing works, the strata condition is so poor that uh, even the rock is very weak, even the walls are weak, even the ore strength is also very less, then we have to go for what is called as square set stopping. As such, this stopping method as on date is obsolete. It is nowhere used, as you can see, it is an structural, three, four members called as a strut, post, and girth. They are used just as we see the being supports being given in slabs and everything in construction. This kind of structure is being used to go up, and this structure, the post, the girth, and the cap, they provide a support to the overbody. If this is our overbody, they are going to provide the support. So this involves a hell of a timber being used in the stoves, and that's why these methods have become obsolete. Another variation is called as a stull stoping. The stull is basically supporting a a prop here. A prop is being given between the two walls, if, but it is perpendicular, more or less perpendicular to the inclination. So this prop is called as stull stoping. Okay, so stull is a prop which is set between the two walls, hanging and foot wall. So this is another timber method, very highly costly, and also the stull is important here. So that's why this is also not being used anymore. This is typical of stull stoping. Okay, hanging wall to foot wall, we are keeping the stalls here. As you can see, this is an overhand method where you can see so many dotted lines which are called as stalls, and still stalls won't suffice. In many cases, you also require these area to be filled up with waste. You can see, as you can see everywhere in these diagrams, that using the stalls as well as the field material is also, then it becomes a very costly method. Next category of the method is called as caving, wherein the strata is allowed to cave, the ore body is also allowed to cave. It is very similar. The first method is very similar, where we call it as a sub level. Again, we make the sub levels and start caving, allowing the caving from the top levels. Okay, so this is sub level caving. Massive or tabular ore bodies, they are more than 50 degrees inclination. The competent ore body is required. It has to be fractured, stable, and it is caveable. Very important that the strata should be caveable. Then only we can go for caving method. What we do, what we further require is that there should be stability in the ore body, and we are required to support extensively whatever the drivages we are making inside the ore body. So this is the way that we can see in this typical layout plan, that the drivages are being made, and haulage drivages are made across the ore body from one wall to another. And if there are two cross sections, AA and BB, if you are able to see how these cross sections are taken, this is the arrangement. This is A and BB. So suppose I am on the right side, I am seeing a plan and I see an ore body. AA is the direction of the strike of the ore body. What I have done, that I have taken a cross section of the ore body. So, and BB is another cross section along the transverse direction I have taken. And this kind of one, this is the shaft, this is the main cross cut, and then there is a haulage road. This is the haulage road which is parallel to the strike of the ore body. From this, the transverse galleries and sub levels are driven inside the ore body. Okay, so let's see that how this AA and BB look like. So AA, this is the frontal direction. You will see that these levels, sub levels are driven in the ore body, but very importantly that one above, they are not one above level exactly, the sub levels are staggered exactly in between, as you can see in this diagram. And the BB layout, if this is to be seen, the cross section is to be seen from this side, it looks like this, that you have got these levels. So these sub levels are being worked from top to bottom and in the caving fashion. Now you can see that one level, two level, three level, these are all sub levels, and every the strata is being allowed to cave here. The strata is being allowed to cave. The most importantly, the ore also caves in along with the strata, and there is always a chance of dilution here. Okay, yeah. So this is a typical of sub-level caving method, and we can see here that The bottommost is that we are drilling this sub level. Now this in here the sub level is being drilled, so it is being supported, and what is being done that the long hole drills are made in between the two holes. Okay, and at the upper level what we can see, the this portion of the ore body has been blasted, the ore as well as the caved hanging wall material, it comes down here. This is very heavily supported. This drive is very heavily supported. There is an LHD or LHD, as you can see here, the LHD, many times it is a remote control LHD which is being used here. Okay, and this LHD is connected to the ore pass, and it collects the material in the bucket, retreats back to the original position, and drops the material onto the bin or and passage which is connected to the ore pass. So this is a classical sub-level stoping, very productive, very high productions are possible, and of course the caving of the strata is allowed here. Okay, yeah. This is another diagram. The way with what we can do is there are two variations in here, that how we allow the strata to cave in is by forming what is called as a slot here. This drift is created, and this drift is basically, if you are doing this drift is from one sub level to another. So entire drift is created like this. It forms a slot here, and this triggers the strata to cave in. If this slot is not possible, if this slot or the top raise, the small raise is not possible, then we go for the drivage of these kind of holes and then blast it. So what happens that this much material blasts down, and this triggers the craving, and the material starts flowing in this drivage. So this is a typical of sub-level caving. Another a classical method, a very high productive mass mining method, is called as a block caving. Okay, so what we do here, if you see the plan view, this is the side view, this is the section that one drift is created in between the ore body. This is the plan on this right side. This is the plan of it. This how this drift is across the strike length of the ore body. Okay, now further two more drivages are made here. These drivages you can correlate here. Okay, this is again the cross section. This is the plan view. Okay, so this drivage is here. This drivage is here in the plan. You have to understand this drivage is here. Okay, when we are looking from the top, so we will see this one as this, we will see this one as this, and this the yeah. So the finger raises are built here. Finger raises are built at an inclination. Okay, and this way the entire drift is developed. So what is going to happen, that we are going to divide this property by this crisscross, and an undercut level is been created here. Now the undercut level is created. Okay, and the entire upper portion of the strata is allowed to cave in, so it starts caving in, and it is it start accumulating in this undercut level. So let's see in some of the advanced diagrams how it forms up, and eventually this kind of finger ray system, they becomes this kind of bins, as you can see in the right side diagram. They becomes the bins here. Okay, and the entire portion from the top starts caving in here. If caving does not happen, then it is a very difficult proposition. You have to instigate it by some mild blast or something. You'll have to do something that the strata caves in. As now you can see the this much portion will all cave in, and it is coming up through these two finger raises, and this drivage has to be tremendously supported, very well supported, then only you can live in this. Then you can collect the entire material. So this is a typical of the block caving method, and there are so many combinations of how we can keep the these drive galleries. If they are too close, then the effect of draw point spacing on what is called as a zone of draw will be, this is a very typical theoretical ideal spacing that this the zone of draw is not affecting. But if they are too fall, then there will be spaces in between the zone of draw, and the in between material may not cave easily, it will create a problem. So the spacing between these drifts is very important. So as to consider from the standpoint of view the zone of draw, I think every diagram you can see the zone of draw. Okay, so either they should not be very close enough, they should not be very long enough, and this is where the spacing is more. If the spacing is very less, then there is a chance of what is called as a dilution. Okay, so this is typical of, as you can see, that how the center of draw, they are brought together here very closely. This is one plan hexagonal spacing, and the these are forming, if you say the shape, they are forming as hexagons, and these are typically of the square shapes of square spacing is between the center of draw. Okay, so this is basically the block caving method, where the undercut level is very important. Okay, so we have covered three types of methods. One, the unsupported method, where the unsupported methods we have seen as the open stoping, sub-level shrinkage stoping. Then we have covered the supported methods like cut and fill, stull stoping. Then there is a method which is called as uh, square set stoping, and there is another classical old approach to narrow over bodies. It is called as raising. This is also an supported method which is specifically designed for narrow over bodies. Then what we have seen here is the sub-level caving, block caving, and in some of the cases, in earlier ways, there was another method which was extensively used, was stop slicing, which is also nowhere used nowadays. Okay, so I think I should stop here now, and see you. Best wishes to all of you for your examination. Okay.
Sir, shall I end it?
Yeah, we can end now.
Okay, okay, sir. Thank you.